Hello. So today what I want to do is once again work with these industrial proximity sensors and use them to be able to take in or interpret a digital signal instead of an analog signal like I've done in the last two videos. I'm going to do both a PNP and an NPN, and I'm going to start off with the PNP. That's the most complicated one to deal with, but let's take a quick look at it. In case you're only watching this video, a quick review here, what I've got. I've got 12 volts coming into this Patton Robotics motherboard, which then means that with the setting set at VN, this entire center row of pins is going to be getting 12 volts. This outer set right here is going to be a common ground, and the inner set is all hooked directly up to the signal pin of this Arduino compatible Teensy. And this entire row of female sockets is hooked up to the same I/O pins. The only difference here is this very last one. This one is hooked to ground, and this one is hooked up to the voltage row, which is currently set to 12 volts because it's set at VN. On this side, I have it set at 5 volts, which means the center row are all going to be 5 volts. The outer row is going to be ground. The inner row is going to be hooked to the I/O pins. And just like the other side, this set right here of female sockets is going to be hooked up to the I/O as well. But we're not even going to use this particular side of the board. Currently, I have it going through this dongle. Okay, the computer is hooked up via this dongle. The power jumper has been disconnected. You can kind of see that through the video there. Okay, so it is not connected power-wise to my computer. No 5-volt supply is coming, and nothing can make it back. Only data is currently connected, and that's to just make certain that nothing goes wrong between my 12-volt supply and my computer over there. So if we follow these wires here, okay, remember, like I said, this red one is hooked up to the center row, which means it's getting 12 volts. The black one's ground. I have them hooked up on this bus over here, red being positive, blue over here being negative, and I'm using this this sensor, and I have the brown wire hooked up to the positive and the blue wire hooked up to the negative. So I'm powering this particular proximity sensor, this PNP proximity sensor, at 12 volts. And this black wire then becomes the output. So what I want to do is I want to be able to safely, in the last video I actually took a 1 to 5 voltage divider and I measured it. Okay, so I was able to take this, what should be a 12 volt on off situation when the metal gets close to the sensor, and we measured that voltage and made decisions based upon an if-then statement on an analog voltage. This time I'm actually going to build a simple voltage divider circuit, and I'm going to be looking for a digital high or low. And to do that, I'm going to take advantage of an online source. Okay, so we have to make a voltage divider. We can't send 12 volts. Let me go back to my video. We can't send 12 volts into this board here. It would simply be too much. It would damage it. Let me focus that ever so slightly. There we go. So we need to cut that 12 volts down. The Teensy, sorry, I exit that again. The Teensy is a 3.3 volt device. It's 5 volt tolerant. So a digital high, okay, is going to be somewhere between about, I think it's 2.7 to 3.6. It'll interpret it as a digital high. So we need an output voltage to be in that range. Okay, now I'm going to go to this video here. I'm sorry, this website. And so we essentially need to build a circuit like this, okay, where this is my source. The source is going to be the output of my PNP sensor. And I'm going to have to choose two resistors that will give me an output voltage of around 3.3 volts. I've already run it here. I should maybe just clear this out. Is there a clear button? Let's just start over so you can see what I did. Okay, so my input voltage is going to be 12 volts because that's what's going to be coming off the PNP. I'm feeding it 12 volts and it's going to signal a high of 12 volts when it gets in proximity to the metal. I'm going to be using, I like using 10Ks, I got 1,000 of them, so I'm going to go ahead and use a 10K resistor down here. Okay, and I want my output voltage, like I said, to be between 2.7 and 3.6. We might as well make it right as close as we can to the 3.3 that the Teensy is rated at. So I'm going to set that at 3.3. And I'm going to calculate. And we can see that the ideal resistance for this particular resistor is going to be 26,363 or 364 ohms. I have 27,000 ohm resistors at 27K, so that is exactly what I've done. Now so here you can see I've taken, and on the position here where the black wire comes out, I have a 27K, and then I have it going to a 10K, which is going to ground. So these two resistors are hooked in series. Let's look at this diagram one last time. So if we follow it out, this one here is here's the positive side, this is my output. We're going to see this 27K right here, and if we followed it down, the 10K would go to the common ground. So what we need to do is we need to take line out here right between where those two resistors connect and the common ground. So let's just do that. I'm going to take this jumper here and I'm going to put that there so it shares the same connection, and we'll check it quickly here with my meter. And let's see, I'm going to move this so you can well, you can actually see the red. Yeah, you can see the light turn on, indicating it's getting close to my metal object. So in theory, if I take and probe this one here and this one here, my meter should essentially be reading 0, which it is. And now I'm going to put it in proximity. You can see the light came on here. And once again, put this here, put this here. And we come up at 3.12 volts, which is a little low, but there tends to be a little bit of a voltage drop from the source. It's probably not putting out 12 volts. In fact, actually, let's measure that. We're putting in 12, but we're actually only getting 11.68. So that makes sense, but still, that gives us well above the 2.7 and safely below anything that's going to cause damage to the chip. So we're at 3.12. So that would mean that if I plug this line into a digital in, for example, I'll choose pin 11, okay, and the Teensy, and let's open up a hunk of code. And once again, I'm just going to take advantage of an example. We'll go to the example, we'll go to basics, and let's just go digital read serial, and we'll put that one right here. Okay, with push button, it doesn't really matter, we're just going to be reading serial. We're looking for a high, low, yes, no, so let's set that. I just set mine to pin 11, so I'm going to change that to an 11. Opening up a serial port, we're going to set pin 11 as an input, and we're going to do a digital read of pin 11, and we're going to display that in the serial window. Once again, 1 millisecond is a little crazy. Let's go with 500, so every half second we'll go ahead and do it. I'm going to upload it. Let me pause while it uploads. Okay, so I'm going to move this out of the way, and we've opened up a serial window. Move it down here so we can see the red light, and we're getting ones and we're getting zeros, so it is on and off. Okay, so what I'm going to do right now is I'm going to interrupt this video, Actually, maybe I'll shoot it into 2 different videos. We'll end this one, and I'm going to now shoot a video with the NPN device. And we'll do something similar like this. We'll do an on-off condition, and then I'll do another quick one where we actually make it do something, turn on and off a fan or something along that line, as well as be able to query the state. So hopefully this is useful, and I'll see you again soon.